Good morning, ladies. It's Mr. O'Sullivan. Today is a Zoom lesson. We are going to be covering 5-1B, Systems of Equations by Substitution, day number 2. So please make sure you watch this video in case you missed the Zoom or if you need further assistance on your Delta Math assignment. So as you remember, before the break, we learned how to solve a systems of equation by using substitution. So what we're going to be doing today is we're just going to be doing 4 problems that are based off substitution. So here's a quick model problem that you can look through. Here are the steps for solving a systems by substitution. You isolate one of your variables, your x or your y. In this case, your y is isolated because you know y is equal to 2x minus 1. Then you're going to substitute that isolated expression from step 1 into your other equation, which is exactly what we did. We have a 3x plus 2y, so we put our 2x minus 1 in for a y. We then solve our new equation for x or y. In this case, we're solving for x because everything's in terms of x. Then we're going to substitute that value we found to either one of our equations. So after we solve this equation, we got x equals 4. Now what we're going to do is we just plug it into one of the equations. We plugged into the y equals 2x minus 1 and then got 7 as our final answer. We could have also done the 3x plus 2y equals 26 and still gotten a correct answer. I'll show you. So if I know x is 4, and I have 3x plus 2y equals 26, and x is 4. Everywhere I see an x, I plug in 4. So I get 3 times 4 plus 2y equals 26. 3 times 4 is 12. So I get 12 plus 2y equals 26. Have to subtract the 12 on both sides of my equation. So I get 2y equals 14, and then divide by 2 to get y equals 7. And if you look, I got a y equals 7 right here. So I know both ways will work. So if we do these next 4 questions, it says in the directions we have to solve them by using substitution. So giving you the heads up, on a quiz or a test, I will be telling you what method I want you to use. I can say I want you to use substitution, I want you to say elimination, or graphically. Sometimes it'll just say solve algebraically, then you have to choose, do I want to do substitution or elimination? If it says solve graphically, you have to graph. Whatever I tell you to do, you've got to do it, okay? You need to show that you know how to use each of the methods of solving. So our first system is x equals 14 minus 2y and 3x minus 4y equals 2. The first thing I have to ask myself, do I have an isolated variable? I do. X is isolated. So everywhere I see an x, I'm going to put a 14 minus 2y. So if I look, I have an x right here. So I'm going to do substitute it in for that x right there. So we know 3x minus 4y equals 2. So I always rewrite the equation I'm going to substitute in. And everywhere I see that x, I'm going to put a 14 minus 2y. Now that I have a number on the outside of my parentheses, I'm going to distribute that number. 3 times 14 is 42. So I have 42 minus 6y minus 4y equals 2, because 3 times negative 2 is a negative 6. You have to combine your like terms, ladies. Combine your like terms. I can combine my minus 6y and my minus 4y. When I combine those, negative 6 and negative 4, that gives me a negative 10. So I have 42 minus 10y equals 2. Now I have to ask myself, how do I get rid of that 42? I'm going to subtract 42 from both sides of my equation. So I get negative 10y equals negative 40. Now I got to ask myself, how do I get rid of my negative 10 or cancel it out? I divide both sides of my equation by negative 10, leading me to get y is equal to 4. Here's the issue. I'm not done. I want to know what x is as well. If you look, you already have an equation in terms of x. I know x is equal to 14 minus 2y. So everywhere I see a y, I'm going to substitute a 4. So I have x equals 14 minus 2 times 4. So I have x equals 14 minus 8 And then 14 minus 8 is 6. So x is equal to 6, y is equal to 4. And you should always write your answer as an ordered pair. All right, let's go on to our next example. I have y equals 2x and x plus y equals 9, so I have to ask myself, is one of my equations isolated? Or a variable isolated? Yes, I do have a variable isolated, my y. So everywhere I see a y, I'm going to substitute a 2x. Again, we always rewrite the equation we're going to be substituting in. So I have x plus y equals 9. I know that I'm substituting in a 2x, so I have x plus 2x equals 9. I have to ask myself what 1x plus 2x is. It's 3x. So I get 3x is equal to 9. How do I get rid of that 3? Divide by 3. So I get x is equal to 3. Now I need to solve for y, so I'm just going to plug it back into my first equation because that's pretty straightforward. I know that y is equal to 2x. I know that x is 3, so I have y equals 2 times 3. So I get y is equal to 6. So that's my final answer, 3, 6. Let's go on to our next example. In number 3, I have y is equal to 6 minus x and 3x minus 4y equals 4. I've got to ask myself, is one of my equations isolated? Yes, one of my equations is isolated, but one of my variables is isolated, I mean. In this case, my y is isolated, so everywhere I see a y, I'm going to be substituting 6 minus x. 6 minus x. So in my equation, I have 3x minus 4y equals 4, so I always rewrite that equation. So 3x minus 4y equals 4. I'm going to substitute that 6 minus x in, so I have 3x minus 4 times 6 minus x equals 4. I'm going to distribute my 4 to each term on the inside of my parenthesis. So I have 3x minus 24 minus 4x equals 4. I'm now going to highlight my like terms of 3x and a minus 4x. 3x minus 4x is negative 1x. Now, I have to... Ooh, negative 4 times negative x is positive 4x. My apologies. This actually messes up the equation. I knew I did something wrong. Okay, so I get 3x minus 24. Negative 4 times negative x is positive 4x, and that's equal to 4. Combine your like terms. 3x plus 4x is 7x. Add 24 to both sides of your equation. So I get 7x equals 28, and then I divide by 7. Now that I know x is 4, I just plug it back into my first equation. Y is equal to 6 minus x. So y is equal to 6 minus 4. So y is equal to 2. So 4 comma 2 is your final answer. Now let's go into our final equation. I have x equals y minus 4 and 4y minus 3x equals 14. The first thing I have to ask myself is one of my variables isolated? Yes, my x is isolated. So everywhere I see an x, I can plug in a y minus 4. So I rewrite that second equation of 4y minus 3x equals 14. I now make that substitution of y minus 4 for x. So I have 4y minus 3 times y minus 4 equals 14. I distribute my 3. So negative 3 times y is a minus 3y. Negative 3 times the negative 4 is a positive 12. And that's all equal to 14. Combine those like terms. 4y minus 3y is just y. So I get y plus 12 equals 14. Got to subtract 12 from both sides of my equation. And I get y equals 2. Now I pick my favorite equation. I like the first one because there's not as much solving. So I have x equals y minus 4. I know y is 2, so I have x equals 2 minus 4. So I get x is equal to negative 2. So my final answer is negative 2, 2. And that's it for today. If you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.